Good day, students. We are done with coordinate geometry 1 and 2. We are done with that topic. Today we are going to start a new topic, and that is trigonometry 1. Trigonometry 1. Under this trigonometry 1, so our first video number 1, is going to be on the basic principle underlining this trigonometry 1. So, in this video number 1, we are going to discuss about the trigonometrical ratios, formulae, and so on like that. Now, we are going to start with the basic trigonometric ratios, very basic trigonometrical ratios. Three basic trigonometrical ratios and their inverses. The three basic trigonometric ratios are sin theta, cos theta, and tan theta. Where theta is an acute angle, in a right angled triangle. See figure 1. See figure 1 below. This is the right angle. Remember, we call it the right angle triangle. So if this is A, B, then we have vertex C. So let the acute angle be this theta. Let that angle A be theta degree. Let it be theta degree. Let that angle be theta degree. Now, using the usual notation, using the usual notation, the side that is directly opposite that angle B is labeled small letter B. The side that is directly opposite this angle 90 degree, which is the hypotenuse, is small letter C. Small letter C. The side that is opposite this angle A, this very angle A, is denoted with small letter A. That is the usual notation I'm referring to. That is the usual notation. Now, the trigonometric ratios. The trigonometric ratios are as follows. Now I start with sine theta. What is the trigonometric ratio for this sine theta in that triangle? So we have as follows. Sine theta is equals to opposite over hypotenuse. So, and the opposite, the side that is opposite this angle theta is small letter A over the hypotenuse. The hypotenuse is the longest side of that triangle, which is the side facing angle 90 degree, and that is small letter C. Now, cos theta is equals to adjacent over hypotenuse. The adjacent, the side, apart from the hypotenuse, the side that is adjacent to that angle theta is small letter B. That side AC, which is small letter B. B over the hypotenuse, which is C. So, tan theta now. Tan theta is equals to sine theta over cos theta. Sine theta is equal to tan theta is equal to sine theta over cos theta. And what is sine theta from here? Sine theta is A over C. That is A over C over cos theta, which is B over C. So this means that tan theta is equals to A over C times C over B. This C will cancel, and that will be A over B. So that is the expression. These are the three trigonometrical ratios. Now they are inverses. The inverse, the inverses of these, three trigonometric ratios are cosecant theta, which is cosecant theta, which is abbreviated as cosec theta, and cosec theta is equals to 1 over sine theta. Cosec theta is equals to 1 over sine theta. Then we have secant theta, which is abbreviated as sec theta, and sec theta is equals to 1 over cos theta. Finally, we have cotangent theta, which is also abbreviated, which is abbreviated as cot theta, and cot theta is equals to 1 over tan theta. So these are the inverses. So from here we can now come up with the trigonometric formula. 1. It's trigonometric formula. Trigonometric formula. The plural form of formula is formula. If it is 1, we call it formula. But when you have more than 1, we call it formula. So trigonometric formula. 1. We said tan theta is equals to sine theta over cos theta. Then 2. We have sine square theta plus cos square theta is equals to 1. Now we have 3. We have 1 plus sec square theta is equals to 1 plus sec square theta. So 1 plus tan square theta. 1 plus tan square theta is equals to sec square theta. Then 4. We have 1 plus cot square theta is equals to cosec square theta. So these are the main trigonometric formulae, and they can be derived. These four trigonometric formulae can be derived as follows. It can be derived. Remember, I call this right angle triangle as figure 1. Now, in figure 1, recall that we said sine theta is equal to opposite over hypotenuse, which is A over C. Call this one equation 1 remarkable. Cos theta is adjacent to hypotenuse, which is B over C, equation 2 Roman figure. Now, tan theta, that is, we are now to prove, we said we're going to prove this for trigonometrical formulae or rules. So, to prove tan theta is equals to sin theta over cos theta. What to prove is proof. Left hand side is equals to tan theta. And from the triangle, from that triangle ABC, tan theta is opposite over adjacent. Tan theta is opposite over adjacent, which is A over B. Then the right hand side is equals to sin theta over cos theta. And we said sin theta from equation 1 is A over C over cos theta from equation 2 B over C. So this is equals to A over C times C over B. C over B. C will cancel. Then I'm left with A over B. Now, which is the same thing as the first sentence. So, since the left hand side is equal to the right hand side, then we can conclude that since the left hand side is equal to the right hand side, then we can conclude that tan theta is equal to sin theta over cos theta. True. So that's how proof. So now you have this formula in your mathematical table. It is allowed. You can always refer to your math table, lift it and use it in any case or exam. So that is that. Then the second one, we are also to prove that sin square theta plus cos square theta is equals to 1. Proof. From figure 1, which is the right angle triangle, we can see that sin square theta plus cos square theta, we said is equals to 1. So this means that sin theta all square plus cos theta all square is equals to 1. And from that figure 1, we said sin theta is equals to, we said sin theta is A over C. So this means that A over C all square plus cos theta. In equation 2, we said cos theta is B over C. B over C. Now, is it equals to 1? So that is going to be, what do I have here? Is it going to be equals to 1? Question mark. So this means that A square plus That is a square over c square plus b square over c square is equals to 1.
You put square there. Square.
1 square, right?
No. Huh? You put square there, b over c.
Here. Yes. B over c square. Now, what is the LCM here? The LCM here is c square. The LCM here is c square. So you can multiply throughout by c square. Let me call this one equation, just for reference. Equation 1. Multiplying 2 by c square. Multiplying 2, multiplying equation 1, multiplying equation 1 by c square. I have, if I multiply equation 1 through by c square, I'm going to have a square plus b square is equals to c square. Is equals to c square. That is equation 2. Now, in triangle ABC, which is figure 1, in triangle ABC, I can say that since the triangle, which is ABC, is right angled at C, then A square plus B square is equals to C square. Why? Pythagoras theorem. So this is equation 3. So since equation 2 and 3, are equal or same, then we can say that sine square theta plus cos square theta is equals to 1. Proved. Then the next thing is to prove that 1 plus tan square theta. The next thing is to prove that the next thing now is to establish or prove that 1 plus tan square theta is equals to sec square theta. Also, we are to establish or prove that 1 plus tan square theta is equals to sec square theta. Proof. Now, we do know that from equation, from the second formula, i.e. sine square theta plus cos square theta equals to 1. We can divide through by cos square theta. We can divide through by cos square theta. And if you do that, that means I'm dividing this formula number 2. I am going to divide through by cos square theta. So I'm going to have, if I do that, I'm going to have sine square theta over cos square theta plus cos square theta over cos square theta is equals to, I'm dividing through by cos square theta. It's going to be equals to 1 over cos square theta. So this is sine square theta. So this means that sine theta over cos theta all square plus cos theta over cos theta all square is equal to 1 over cos square theta or 1 over cos theta all square. Now, we do know that sin theta over cos theta is tan theta all square plus cos theta will cancel cos theta, and that will be 1. That is going to be 1. Is equal 1 over cos theta is the inverse of cos theta, which is going to be sec theta. 1 over cos theta is sec theta square. Therefore, I can now conclude that tan square theta plus 1 is equals to sec square theta, or 1 plus tan square theta is equals to sec square theta. Proved. So that second formula has been established. Has been proved. So then the third, no, then this will be the third formula. Then we now establish the fourth trigonometric formula. We establish the fourth trigonometric formula. Now, to prove that 1 plus cos square theta is equals to cosec square theta. We have to prove that. Proof. Recall that sine square theta plus cos square theta is equal to 1. Already proved. This formula has already been proved. So, dividing this formula through by sine square theta. Dividing this formula through by sine square theta gives sine square theta over sine square theta plus cos square theta over cos square theta over sine square theta. Sine square theta is equals to 1 over sine square theta. That means dividing each and every term of this formula by sine square theta. Sine square theta over sine square theta, they cancel each other, and that will be 1. Now, so what do we have? This means that 1 plus Cos square theta over sin square theta is the same thing as cos theta over sin theta all square. And that is equal to 1 over, this 1 over sin square theta is the same thing as 1 over sin theta all square. Therefore, I have 1 plus, now, cos theta over sin theta is the same thing as, remember, cos theta over sin theta is the same thing as 1 over sin theta over cos theta. And what is sin theta over cos theta? Sin theta over cos theta is the same thing as tan theta. So this is the same thing as 1 over tan theta. So, what am I saying? This and 1 over tan theta is cot theta. So this is the same thing as cot theta all square, which is equal to, now 1 over sin theta is cosec theta. This is the same thing as cosec theta all square. Cosec theta all square. Therefore, 1 plus, from here, 1 plus cos square theta is equal to sec square theta, proved. So, that is that. These are the 4 trigonometric formulae